Okay, last time we started about vectors. Today we'll be describing how to, like in today's lesson, we'll be doing representation of vectors. Addition and subtraction component of vectors. Okay, we'll be trying to cover these things in today's lesson. Now, number one, how do we represent a vector? Representation of vector. First of all, the question is, why do we need a representation? Well, we don't need representation for scalars. Scalars can be easily understood. All you need to do is just write a number with a unit. That's it. Why we need a diagrammatic representation of vector? The answer is because it will give a visual about the direction of the vector. Otherwise, if you don't want to do that, just 1 second. Somebody's asking for the link. Okay. So why do we need a representation? Because a diagram will give an idea of magnitude as well as direction. Otherwise, if you have to describe a direction, it will need too many words. And with every vector, there will be a lot of information in word form associated over there. Plus, if you have multiple vectors, it will all like it will be a mess. So how can we solve it? By just making a diagram that represents the vector. Okay. So representation of vector is any vector can be represented by a line segment with an arrowhead on one end. Length of line segment is the direction. Sorry, is the magnitude. And for direction, arrowhead assist or arrowhead is used. So a line segment means a piece of line, a piece of line that has a certain length. Okay. The length of the line segment depends on magnitude of the vector, and the arrowhead gives us information about the direction. For example, is important. Every accurate vector diagram. What is meant by accurate vector diagram? Accurate vector diagram means a vector diagram that is drawn to the scale. not like random lines just showing the direction and shape of the vectors. Sometimes we sketch a diagram without any accurate measurements. That is not an accurate diagram. An accurate diagram means that every dimension, every length, every angle is measured and drawn as it should have been drawn. So that kind of diagram is called an accurate diagram. Every accurate vector diagram requires information for scale of diagram. Like how much of the quantity is represented by each centimeter on the diagram? Let's see. Example is velocity of 18 meter per second towards north. Number two, acceleration of 0.87 meter per second square downwards. Displacement of 379 meter towards east. Momentum of 550 kg meter per second. So towards left. So there can be many other examples. I will start with these four. Number one, I have to select a scale for each one of them because they all are different. So I cannot use same scale for them. One is a velocity, other is acceleration, displacement, momentum. So I need separate scale for each one of them. What should be an appropriate scale over here? Remember, you have to draw these vectors on a paper. A paper in your exam is of almost a definite size. It is almost the size of a paper in your notebook right now. So what is a good size or good scale for this thing? Like it should be good enough that we can see it. For example, if somebody makes 10 meter per second for each centimeter, that would make a line of 1.8 centimeter, which is a very small length as compared to the size of the paper we have. So that won't be a very suitable scale. And if this is the only vector you have to draw. Or if you take 1 meter per second for 1 centimeter, that means you have to draw a line which is 18 centimeter long. Again, that is not a very good selection. So if I have to select a scale, I will go with 5.0 meter per second is represented by 1.0 centimeter. So 5 meter per second is represented by 1 centimeter for this thing. So that means this vector will have, if it is 18 meter per second, so what is 18 divided by 5? 3.6 centimeter for this vector. Now, what should be the scale for this kind of vector? 0.87 meter per second. Now, if I go with 0.01 meter per second square for 1 centimeter, I would need 87 centimeters. That is like very, very close to 3 feet. So that is not a sensible choice. That would be a sensible choice. So think again. I think 0.20 meter per second square should be represented by 1.0 centimeter. That will make a total length of 4.4 centimeter. So a 4.4 centimeter is a reasonable length. It will be almost like these 4 boxes, actually 4.5 boxes. This is a reasonable size of line on a paper. (379 meters towards east). I will go with 100 meter are represented by 1 centimeter. So this will be 3.8 centimeter. 100 kg meter per second is represented by 1 centimeter. So that will make this 5.5 centimeter. So remember, scale should not be very large that the vector becomes very small, and scale should not be very small so that the vector becomes extremely large that it cannot fit into the paper. So, and we will be practicing some questions and you will understand what I mean. Now, resultant of vectors. Listen, let me give you an example. Let's say this is a classroom. Now, okay, let's say if this is a classroom, these are the chairs for the student. There is a teacher rostrum over here. This is a whiteboard. This is a door. Okay. Now this is the top view of the classroom. This is where a teacher is standing. Now, if I'm in a classroom and I have to demonstrate what is meant by resultant of a vector, this is how I do. I normally have, every classroom has a duster in the class. I hope you can see this red spot over here. This showing the position of a duster. I asked every student in the classroom to remember the position of the duster over here. And then I make it go from there to a student's desk over there. So what did I do? I have displaced the duster. Stay with me on this one. So what will be the displacement of this duster? How will I show displacement? You would say you can draw an arrow with head at the last position and tail at the first position. So this vector, it is not necessary that we always put arrowhead on the end. We can make arrowhead on the belly of the vector. That can also show the direction of the vector. So this vector will start from my desk and end on another student desk. So this is displacement vector number one. Then I displace this duster from there to there. What will be the second displacement vector? You would say it is very simple. It will be from there to there, like this. This will be displacement number one. This will be displacement number two. So remember, what was the starting position of the duster? So there are two displacement vectors. The first displacement vector displaced it from my desk to student A, and then the second displacement vector displaced the duster from A to B. Is this job doable by a single vector? Like, is it possible that one vector can do what these two vectors did in combination? If your answer is yes, can you tell me where should that vector start from and where should that vector end? So the displacement vector will be from my desk to B's desk. This is resultant of S1 and S2. So for finding resultants of vector, diagrams are very important. It is not only the number, it is also the direction that can affect the size of the resultant. So
Why am I the hostess?